HackTheBox is hosting the Stack Smash CTF this upcoming weekend, July 25th through 27th. If you like reverse engineering, binary exploitation, this is the event for you. This is OXTF, and HackTheBox has a teaser challenge out today that I get the honor of previewing to you. It's called Jumpio Adventure, and let's go ahead and take a look. So on the CTF site here, on the upcoming tab, you'll see the Stack Smash CTF, July 25th through 27th. Go ahead and register for that, get signed up, and you can play right when it starts. On the ongoing tab, there's also the live Stack Smash CTF playground, which we can play right now. Let's go ahead and take a look. There's a single challenge, Jumpio Adventure. And if I click on it, Jumpio is roaming in the forest, and suddenly he stumbles upon an angry-looking mushroom-like creature. Jump around and find out. It's game time. Let's go ahead and click spawn to go ahead and spawn up the remote instance. There's also some downloadables. This is going to be very common with your this kind of CTF, where they're going to give us the binary to play with, as well as a remote instance to actually exploit. One of my favorite things they've added recently is I can click on the download link here and it will download, but I'm actually on my host right now in the browser, and I want to download to my VM. So I'm going to click the copy attachment link, and I'm going to jump over into my VM, and I can do a wget. You do want to put it in single quotes so that things like the ampersand don't get evaluated as bash symbols, but it's all one thing. But if I get this, let's see, we can download this to pwn.zip, and boom, we got it. So let's unzip this, and I've got the files. There's two files, flag.txt. Certainly they gave us, fake flag for testing. That makes sense. And then we can take a look at Jumpio's Adventure, and it is a 64-bit LSB executable. It's an ELF. It's a Linux executable. That's about what I got. I think the first thing we should do is just play this thing. So let's go ahead and run it. This is an awesome old school, like Nintendo-looking ASCII art. There's three options in the menu. Exit just says goodbye and exit. That's not surprising. Scoreboard. It prints the scoreboard and then gives the menu. Looks like we got some HackTheBox staff going here. I'm currently in second, it seems. And I like to always knock out kind of the short paths. Like, I don't see anything interesting in exit. I don't see anything interesting in scoreboard. So play is probably going to take the most time. That's why I go there last, just so I can get the other ones out of the way. Let's go ahead and play. And this is awesome. Okay, I got a really old school Mario with a Goomba here, and some attack, health, speed, other stats, damage converted to healing. I'm not quite sure what that means. Let's start by throwing a punch. And it says my punch is brutal. It used charge. His attack is raised. So now its attack's higher and its hit points went up. Okay. Let's give it a curl. And we buckle up. And it used devour, and I'm dead. All right. Let's play again. Let's see if we can do, what is speed run? Nothing super interesting. Okay, my speed went up by 10. And I hit enter without entering anything, and it just exited. Okay. We'll come back here. We'll play again. Use potion. Looks like we have a potion that does our attack, our defense, our speed, I'm not even sure what ACC is. We have one that gives us a bunch of things. Now this one's interesting because it gives us a ton of defense. It also takes away a bunch of attack. Let's try that one just to see what happens. I'm the ultimate tank. Yeah, I guess that's true. Interesting. If you look at our attack now, it's huge. That just reeks of an integer underflow. We'll check that out when we start reverse engineering. I wonder what happens if we throw a punch now for all that damage. My punch is brutal. Yeah. I one-hit KO'd the Shroomer. Impressive new high score. Tell me my name. OXTF again. And we can check the scoreboard. And I didn't actually make... Interesting. Maybe it's capped at 4 characters, because I'm pretty sure that wasn't there before. Let's go back up. Where do we see the scoreboard? Yeah, before. So I did get on there, but it looks like only 4 characters made it on there, even though I put in more. So that's interesting. Basically, there's not much else to look at there. Let's go ahead and exit out of here. The next thing I want to do is reverse engineer this thing. So I'm going to open up Ghidra. This is a free reverse engineering decompilation tool, actually made by the US government, but it's awesome. I recommend it. Let's see, we need a project. We'll open up a new project. We are going to be, let's see, in the Jumpio directory. I'm going to go ahead and create a folder in here called Ghidra, just to keep those files separately. Make that, and we'll call this Jumpio. And we finish. Now, when I do that, what that actually does in here is it creates that Ghidra directory, and inside Ghidra, you can see now I have the, these are the various project files representing that project. So that's what's happening. Let's see. We need to import a file, and we will give it Jumpio's Adventure. It automatically recognizes it's an ELF, and we can just accept the defaults here. And it's going to import it, and now we can double click on it to load it up into the compilation tool. We need to analyze it, so we'll go ahead and analyze it and hit analyze. And we're here. You went too fast, I didn't get to show it, but down here on the bottom right, there'll be like a progress bar showing as it imports. You want to wait for that to be completely done before you start looking at anything, or else you're going to miss stuff. Let me see if I can make this look nicer. Okay, took me a minute, but I've got the font bigger. The first thing I like to do here is to look at the functions. So you can see here we have some functions like banner and battle and fail and frame dummy and info main menu pots, read number setup, show Hall of Fame success, and win. So they're not stripping the function names off, and win immediately seems interesting. So let's click on that. Over here in the decompile, you can see it's opening flag.text, so we can call h flag.text. Let's call h flag. If the flag doesn't exist, it's going to have an error. Otherwise, it's going to read from handle flag into flag, we'll call it, and then it's going to close that handle, say, here's your prize, and print the flag. So this is the function we want to get to. If we click on here and do reference, and then references to that address, there are none. I mean, these are a couple mentions of like data and things, but like that's not useful. So there's no way to just have it call this. So we're gonna have to overflow a return address or something and put this return address there. Let's go ahead and take a look at main. We start off with a banner, so that probably prints us that POW that showed at the beginning. And then we have some stuff here, some strings being formed on the stack. Not exactly sure what those are. Do they get used later? Maybe. We'll come back. So we're just gonna kind of skip through that for now. We enter a while true, and there's our menu. Okay, so the menu is we're gonna call menu. We're gonna rename this like user menu input. If it's equal to 3, that's the exit. We print goodbye and exit. If it's greater than 3, we break out of this loop and we fail with Mamma Mia, what have I done? And we exit. If it's equal to 1, we call battle. If it's equal to, otherwise, if it's not equal to 2, we exit. And then otherwise we call show Hall of Fame with a bunch of this stuff. So this I bet this is like, maybe this is the Hall of Fame, current Hall of Fame values or something. Not totally sure. I don't think that's as big a deal. Following the same thing as before, let's look at, we can take a quick look at show Hall of Fame, and it is just taking a bunch of parameters and printing them out. So nothing too interesting here. We'll go back. Let's look at the menu real quick. The menu is going to print this global. We can look at that global, and it's a bunch of spaces and things, but then here's 1 play, 2 scoreboard. So this is literally just the menu. Rename global menu string. And then we call read number, what that does. It is going to read into local 28. And then it's going to actually, okay, the result of that is actually going to get, that's going to store the length in local 28. And then somehow it's going to pass it to string to unsigned long, which then returns. Now, if we look here, it doesn't think it's returning anything because it's a void, but really the return of this string to long is going to be stored in RAX. And when RAX is here, that becomes the return value for this. So I'm going to go ahead and retype the return ulong, and boom, now it says, oh, okay, well in that case, here's this value, and I'm going to return it. So we can write user selection, or something like that. And that's what read number is going to do. If we go back here to menu, this is actually doing the same thing. So we're going to retype it to ulong, and that's fine. Let's go back out of menu. And now, you know, that's where it's actually being stored. So it could tell that it was supposed to get an integer from this function. It just wasn't quite typed right. Let's go to battle. That's really all that's left to look at. There's a loop up here at the very top. Do, let's see, where's the bottom of this one? Is it all the way? So all the way at the bottom, do while true. So this whole thing is one big while true until it breaks. And And at the very beginning here, we have if something is less than 1 or local 18 equals 0. And then if that's less than 1, we print monster with strong, game over. So this almost seems like user health, player health, call it. Otherwise, it says that's impressive, and it reads our name in, and it string copies it. And this is already very interesting because, okay, we're reading our name in to local 58. We're reading, remember how only 4 characters got taken? Now that makes sense here because we're reading into local from standard in to local 58, and then we're taking that result and we're copying 4 bytes of it into parameter 1. But why are we reading OX200? That's like 500 bytes. That's a lot, and we're only reading it into local 58, which is a 32 byte buffer. So that's a problem. That's a buffer overflow right there. So let's read this name input raw, and we're almost certainly got a buffer overflow there. We're going to want to look at that. We can look at the rest of this real quick. You can see, I guess first thing we do here is we clear the screen, we print out all the stuff. We call read number again, and so this will be like our another rename variable user input. If it's equal to 4, we call the pots function, and we'll call this like potions input. Else, if it's not, we do all this other stuff. If it's bigger than 4, we print I'm dizzy. Then if it's 3, we make these are the different things. My punch is brutal. Doesn't even seem like it. If local 18 is greater than local, or if local 20 is greater than local 18, I bet you that must be like, let's see. I'm guessing this is the attack, and let's say this is rename variable monster health. If it is, then we're going to say we got it and we set monster health to 0. I bet you that's up here in this loop. Yep. If monster health is 0, then that's so the 2 things that are going to break us out of this loop are if the player health goes less than 1 or monster health is 0. If monster health is 0, that's where we get this right here. So cool. We're seeing where that goes. This is all this else happens if we aren't inputting a 4. If we're doing the potions, then we need to do the potion input. We need to come down here. We're going to switch on potions input. By default, that is set to 539. Maybe that's elite. So nothing nothing happens if default. But here's the different potions, so you can see our attack gets stronger. This is probably our defense. We could look into the program and figure all these out, but I don't think they really matter. So we've already got a buffer overflow. But you will see here's where attack minus 2000. If we look at attack, if I center click on that and go up to the top, we can see it's an unsigned integer. So as soon as I subtract 2000 from 10, I'm going to roll around. That's my buffer, my integer underflow, and that's why my attack gets so high. And that's how I win the game. I think that's all we need. We can see, what is this? What's local 34? It starts off as 1. Okay, and if it's less than 2, then it's going to do it. So this is like kind of the attack. Let's see. So this will be round counter. In the first round, it's going to charge. It's going to, looks like maybe add to its attack and then increment the round counter. And then otherwise, if the player health is greater than 0 and the monster health, if the monster health is not 0, then we're going to set the player health to 0 and we're going to end. That's going to end it basically. So that's basically it. We've reverse engineered this binary. We understand it. Let's go ahead and check for that buffer overflow. So to do that, we'll run it again. I think, yep. We will put in play. We will, let's see, 4, 5. Then we're going to throw a punch, which is 1, I believe. Punch, we've won. And now we just need to start we need to put in a real long name here. So let's make sure we overflow. Good start. Let's copy and we'll paste a bunch. Okay. And we cored them. So we crashed. And it looks like I kept pasting afterwards. So, but we crashed it. So that's a good sign. We're going to want to run this in GDB. And we'll do Jumpio Adventure just like that. And when I run this, you can see from the prompt that I run with Peda. I'll put a link to Peda in the video description. This is a relatively old school GDB plugin. There are newer ones out there. If you like those better, go with those. I still like Peda. It's what I learned on. But I find having something is pretty critical. So we will hit R to run this, and we will just play 4, 5. 1. I can go ahead and enter that. We just want to get back to where we won. And the goal here is I want to crash it and see what happens. So I put in a bunch of A's, and we will copy and paste that some more. And you can see we crash here at a sig7. Peda, by the way, is what's giving me this whole output of what, the current registers, the current instruction pointer, this current stack, and what's happening. So we've got a sig7. In x64 binaries, when you try to load an invalid address into the instruction pointer, it crashes. And so you can see right here, we're at the return instruction, which should load the return address off the stack into the instruction pointer. And the stack, you can see, is A repeating 120 times. So all A's is not a valid address. That's why it crashes. That's great news for us. Let's run this again. And we want to figure out, I guess before we run, we want to figure out how much do we put in till we overwrite the return address. And so I'm going to run something called pattern create. There's a bunch of different ways to get this, but it's built into Peda. And I just want to get, let's say 200. And that gives me a nice string here, which I will copy, and then we will run. 1, 4, 5, 1. And that should get us back to where it prompts us for our name. Now we got to throw our punch. We one hit KO'd, beautiful. And I'm going to put that pattern in there. And we can now see at the crash, what is trying to get loaded. And so I'll grab the first 8 bytes of this. 5, 6, 7, 8. Is that it? 1, 2, 3, 4, 5, 6, 7, 8. And I'll do pattern offset, paste that in, and it tells us right away 88 bytes in. I always like to check this, so we can do 1, 4, 5, 1. And in the meantime, I will AC in my tmux window and do Python -c print A times 88, like that. So now I have exactly 88 A's. We'll go back to this window. We'll put that in, and then we'll put BB, 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 BB. And we crashed with BB, BB on top of the stack. So we now know 88 bytes of whatever. A's work well, whatever character you want, followed by the return address, and we're going to get a win. Now the return address I want to put in is the win function, because instead of returning back to where I'm supposed to go, if I return to win, I'll run the win function, print the flag. The challenge here is I can't put that in. It's not ASCII. So I need to write, this is where I'm going to have to write a script. Let's get out of here, and we'll do code on this and open up Visual Studio Code. I'm going to go ahead and open up, and we'll call it like solve.py. I'm going to make this bigger so you could see it. I don't want Copilot, although it might be running a little bit. We'll see if it makes suggestions. One tip, never call your script pwn.py. Something I make this mistake all the time, but the first thing we're going to do is do from pwn import star. And if I call my script pwn, it's not going to go try to find the third-party library pwntools. It's going to try to import stuff from this script, and it's just going to fail. So good, just life tip, don't forget that. We'll say R is equal to process, and then we can do Jumpio Adventure, like that. And I always like to just start by doing r.interactive, and opening up a terminal and making sure this runs. Now, first thing I do, I need pwntools is not installed. I'll need a virtual environment. I like to do this with UV. I've got a video showing how to do this. For scripts like this, what you need to do is do UV add script. And now I can do solve.py, and then I want pwntools, if I can spell it right. And what that does is add this nice metadata at the top. Now I can do UV run script solve.py, and it will on its own, it handles like building out a virtual environment, installing pwntools, etc., and then it runs for me. And you can see we are now interacting with the thing. So that seems to be working great. Now we need to get through the menus to the part we can actually throw the exploit. And so we can do r.send line after. And so what do we want to send? What are we waiting for? We're going to wait for this prompt here. So it'll be that in space. And then we next need to get what do we actually want to send? So we need to send, let's see, whoa, how did I just lose my mouse? We then need to send 1. And it would help if I put a B and not an N, like that. And this is to play. I'm going to go ahead and just copy that. So now the next thing we do is we want to do 4 for potion. And then we want to do 5. This will be the int underflow And then we want to do 1, 2, punch. And this should get us to the name here. So I'm going to save that, run it again, and it's taking a minute. Now, because all this is happening in the background before we go interactive, and only it starts printing once we get there. So cool. Okay, so now we want this right here, so name, and we'll do r.send line after that. And what are we going to send? We're going to send payload. And payload we haven't defined yet. So what is payload? Okay, let's come up here and do it. Payload is equal to A, or whatever we want, times 88, plus, and now we need to put in the address of win. And we can do that. We can grab it here. We do this. We do info functions right now. I don't think we'll get it. Oh yeah, we do. Okay, beautiful. So here's the address of win right here. So it's 4015.4f. If you're manually doing this, you're just going to do \x. It's the reverse byte order. So 4f, ox15, ox40, and then we're going to make this an 8-byte address. I'll show you a cool trick on how to do this slicker after we do it the manual way. So that should be 1, 2, 3, 4, 5, 6, 8 bytes. And that gives us our payload, and we might be done. Let's see. Let's run this script again. Getting all this stuff. It's going to go ahead and get to the point where it asks for our name. It's going to send the payload. It's all happening in the background. We're not seeing it. And boom, here's our prize, fake flag. So we have read the flag off of our desktop. That's perfect. Before we go run this remotely, I'm just going to show you another trick. We can say like E is equal to elf, another thing that comes from pwntools. And then we can say Jumpio's Adventure like this. And then for our payload, I'm just going to comment you out. And we're going to put here, we can do P64, so we're making it a 64-bit byte value. And then we just need to do e.symbols.win. And that's going to find the address of win, and it's going to put it into this format for us, and it's just going to do everything for us. We could also find this address. I meant to say, coming over here, if we go to the win function, you can see 4015.4f right there as well. So that's another way to manually do it, but this is really the nice way to do it, is make yourself an elf and do that. And we can just verify that this still works. It's going to take just a minute, and but it should print us our flag. You can see when you load the elf, it does run a check sec on you and print the thing, so you can see whether there's stack canaries or nx or pi, etc. So cool. Did we get? Yep, there's our flag again. Okay, so we're good. Now, the last thing we do is make this remote. So instead of coming down here, let's see, we'll make another space here. I'm going to comment this out. Control / we'll do that. And we can say r equals remote. And I'm just going to go ahead and import sys. And I like to be able to read this from the command line. So we'll say sys.argv1, sys.argv2. And so now if we run this, let's go back. I got to find my test. Did we never spawn? Let's click here. Cool. Address. Paste. Come back. Grab the port. And paste. Put the space here. And so now we're connecting to the remote instance. And with any luck, we should have a flag back in 5-10 seconds. If not, we'll have to troubleshoot. But yep, there it is. We got the flag, and that worked beautifully. So I'm going to call it here. This was, this is an easy teaser. Pwn is hard. If you stuck with me this whole time and you're not familiar with how to do this, like, props to you. This is cool stuff to learn, but it is tricky, and there's a lot of skill and practice that comes with it. But it's really fun. So hope you check out the CTF this weekend, and I'll talk to you next time. Bye.